In western Alberta, the transition from plains to mountains is abrupt. This blue line is the McConnell Fault about 75 kilometers west of Calgary. It runs for 480 kilometers from east of Mayette Hot Springs in Jasper down to the Oldman River in southern Alberta. At the mountain front east of Banff, we can touch a spectacular exposure of the fault contact. Here's the view east over the Bow Valley as it exits the mountains. Notice how flat the view becomes to the east. The Yamnuska is just behind the ridge at left. Erosion in the Bow Valley cuts across the strike of the thrust sheet. Here the fault is almost horizontal. 520 million year old limestone, the Eldon Formation, was thrust over top Cretaceous shale and sandstone of the lower Brazeau Formation. We're heading to this area at the base of the cliff. The angle of the slope here prevents talus from building up and covering the fault. There's hiking trails up both ends of the mountain. At the start you'll see outcrops of marine sandstone. This is the Wapyabi Formation. These little cliffs are sometimes used for early season climbing practice. Higher you'll pass into the lower Brazeau. This non-marine sand and silt was deposited into streams, deltas, and swamps near the shoreline of the Western Interior Seaway. In the final stretch up to the face, the slope is mantled with limestone talus. In some places there are house-sized blocks, which rafted down the slope, presumably in the 13,000 or so years since the Bow Valley was filled and scoured by ice. The face is up to 250 meters high and has more than 140 climbing routes. Hence good advice to wear helmets when you are venturing underneath. Here we're at the fault. Limestone above was laid down in tropical water when this part of the ancestral continent was near the equator. During the Cambrian, life on land was just getting started. The shale below the fault was deposited 450 million years later. The end of the age of dinosaurs was then just over the horizon. What's remarkable is how little disturbed the footwall appears. Just inches below the fault are thin beds of coal, apparently unaffected. The thrust sheet has been shoved perhaps 40 kilometers from the west and from 8 kilometers lower. Studies indicate that the coal rank is slightly higher adjacent to the thrust sheet, indicating modest frictional heating. The shale erodes easily, undermining the limestone. Eventually, sections of the cliff above an overhang will fail vertically. In places, the limestone is layered and appears to have rolled or been folded. Possibly this occurred during transport along the fault. The Eldon Formation was formed in shallow seas which would have stromatolites or algal mounds. Some of the texture we see may be these mounds. At the pass on the west end of Yamnuska, one encounters some shale. I had always thought that this was erosion down into the footwall of the lower Brazeau Formation. This would make Yamnuska a klippa. A klippa is a section of thrust sheet disconnected by erosion. In fact, the Wikipedia article for klippa includes Yamnuska as an example. Other examples in the range are Crow's Nest Mountain and Chief Mountain in Montana. Let's overlay the geology from GSC map 1865. This is Margot McMechan's 1995 Kananaskis Foothills map. It shows a small wedge of slightly older Cambrian rock, the Cathedral and Stephen formations. So the shale at the pass may be Stephen Formation, not the lower Brazeau, and in fact maybe Yamnuska isn't a klippa. West of the Yamnuska, the fault descends. The circle at the bottom of the map is where the Trans-Canada Highway crosses the McConnell Fault, essentially at the bottom of the valley. The rock cut you pass through here is the Eldon Formation, gray on the map. The lower Brazeau is the mustard yellow. The Wapyabi Formation is olive green. Whether you are climbing or hiking, enjoy your visit safely to one of the beautiful parts of Alberta.